Where I say, hi, Marcus. Who are you?
Yeah, I'm a researcher at the Stockholm Environment Institute, and a lot of my work focuses on the Arctic.
Right. And we're talking about the Arctic and Antarctica as well here.
Yeah, both of the poles. And one of the questions, I guess, is why should we care about the polar regions and the Arctic in particular? And we often talk about the Amazon as the lungs of the planet, but the poles, and especially, both poles, are the cooling system for the planet. And as those change, the temperatures will change even more rapidly. So, for example, we know that as global average temperatures or mean temperatures go up, they're going up at roughly twice the speed in the Arctic. And when we send these signals up north and down south, when they come back to us, they come back much stronger, potentially. So there's an amplification that takes place with the carbon pollution and the other effects that we're sending up there.
So the changes of albedo, and that's not only carbon, that's also with the darker land beneath the ices.
Yeah, that's a good example, probably one of the easier examples to understand of this positive feedback loop, where melting opens up more open water and land, which absorb more solar radiation, which then accelerates the melting process. And we don't know where the thresholds are where that pace takes off much, much faster, but we know they're out there.
Okay, and then we have sea level rise as well. And how much are we talking about?
Yeah, it depends on where you are. The irony is that when the ice sheet disappears on Greenland, or as it disappears, most of that sea level rise is going to happen somewhere else, because Greenland, like Sweden, actually rises as the weight of that ice disappears. The other thing that's really shocking, as the ice disappears from Greenland, the rotational axis of the Earth actually changes because of the mass. There's so much weight over Greenland that it shifts the wobble. And you wouldn't think that climate change would actually change the geophysical properties of the planet, but losing ice over that part of the land actually shifts the rotational axis and shifts the wobble. So it's really enormous in ways that most of us never would have imagined.
What kind of scenarios are we looking into, and how much can we stop by mitigating climate change?
Yeah, well, I think there's a lot of discussion about how much climate change is in the pipeline already, sort of already in the works because of the CO2 in the atmosphere and stored in the oceans. And I think a fair amount of debate. But what we do know is that there's a lot of change already in the process we need to prepare for. And if we wait until we see what's going to happen, it'll be too late to avoid even worse damage, worse disruption. And a lot of that disruption will happen along the coast where most people on the planet, or at least a lot of people on the planet, live.
And we're actually kicking off a lot of changes right now, and things will happen for the following centuries.
Yeah, I worked in a project called the Arctic Resilience Report, which was delivered in late 2016. And what we found in that report were there are a whole series of expected thresholds. Some of those we see us potentially tipping past those now. Some of them are expected in the scientific literature, and we're not sure where they might show up. So this feedback effect with ice and snow is one of those. Another one is the conveyor belt in the oceans that carry heat around the planet. So some are more certain than others. But what we know very little about is how these different thresholds or tipping points might interact with one another and take off in some direction that's completely unexpected. So that's actually the thing that worries me the most. When you put all of these changes and potential changes in the same pot and stir it up, what comes out? And that's what worries me.
How does humanity react on those uncertainties? Do we act by sort of assuming that it's going to be a worst case, or the least changes, or?
Yeah, well, there's a lot of inertia in the system. Our tendency is to keep on doing what we've been doing until we can't do it any longer. We may be heading in that direction. And I think the big question is how much disruption will it take before we figure out we have to make a shift. And on the flip side of that, how much benefit do we see from changing the way we use energy, for example, in shifting to energy that's clean and that doesn't pollute our lungs and our water and our air. And so they're both things to avoid by making those shifts, but there are also a lot of benefits to be had. And I think we need a package that includes both of those.
Okay,
for us
so
to
being a scientist, you know a lot about these things, and you talk to colleagues, etc. But when you look at it in the societies, does people and policymakers and business leaders, etc., are they reacting on these things or on other things? Do they know as much as you do? And if not, why?
Yeah, well, I mean, we all specialize, so we all have our areas of specialty where we know more than other people. I think the climate issue feels distant a lot of the time to me too, and when we have a warm spell like we had in Stockholm during May, it's you could think if this is climate change, it's not all bad. The problem is what comes beyond, that stretch of really pleasant conditions, unless you're a farmer, where you're depending on water to get your crops going. So I think we all struggle with this process of changing from something that we feel like we need to leave behind us to something new, partly because we don't know what that something new is going to deliver in practice, and partly because habits are the world's greatest energy-saving device. We just keep on charging forward without having to think about it a lot. But part of what we see with energy, with wind and solar power, is that those things are moving very rapidly. They're actually becoming cheaper than fossil fuels, and they cause a lot fewer problems. They're not problem-free, but they cause a lot fewer problems. And one of the big problems they'll help us to address is, to stop the worst of the carbon emissions and things like from burning coal. That it's not only climate change, but it's also mercury and other kinds of pollution that are extremely harmful, especially if you live close by. Yeah. So lots of reasons to change, but we need to get ourselves on that path a little more vigorously. Yeah. And Sweden's actually doing quite well, and the progress that we make here is not going to have a direct impact globally in the sense that will help to curb climate change. What it will do is show people what's possible, that we can actually make these changes and live really well while doing the kinds of things we need to do to help stabilize the climate and the environment that we depend on.